what you see on the screen are graphs of the function that we've obtained corresponding. The purple one corresponds to a length of 63 centimeters. The yellow corresponds to a length of 50 centimeters. Neither of these is a perfect model of what actually happens, because the model that we've done, complicated as it is really a bit of an oversimplification. We haven't taken account of friction, we haven't taken account of the rolling of the ball, the spinning of the ball as it rolls down, and several other factors that are really significant. So it's not going to be a perfect model, but we can still get the idea of the modeling process and see how this function that involves square roots and power functions and polynomials and a lot of algebra can actually model something that we can observe. Now we actually see on this graph that the predicted maximum for the 50 centimeter ramp is around 39 centimeters, 38 or 39 centimeters, probably more like 38. That corresponds to a height. Remember, the axis here is h. This is h versus the distance that the ball goes. So this is the x of h function plotted this way, and the h, the height of the end of the ramp, plotted in this direction. We actually observed a peak around 36, which doesn't correspond too badly to the yellow graph. It doesn't correspond all that well to the purple graph, but we still observe similar behavior when we actually plot these things. So this is kind of an interesting model, and gives a good introduction to some of the ways that we combine functions and the way we use algebra and a knowledge of the real world to make models.